when you take the drug, okay, so the chemical alternation of that drug takes place inside the body of a living organism, okay. That process is called as your drug metabolism, okay. That process is called as drug metabolism. So when you take the drug or any other foreign compound, okay, so that enter in your living system, and sometime it's stored in your body, and sometime it removed from after some period of time, okay. So when that drugs enter in your living system, okay, so what happen, inside the body they remain intact, or it undergoes some chemical transformation, it undergoes some chemical transformation it undergoes some chemical transformation by variety of enzymes. So your body contain different types of enzyme, okay. So it undergoes chemical transformation. Due to that enzyme, different types of enzyme present in your body, okay. So this result in what the loss of pharmacological activity, okay. So due to the enzyme, okay, due to the effect of that enzyme, sometime what happen, that reduces the activity of a drug, that reduces the pharmacological activity of a drug, okay. And sometimes the drug is less active, or sometimes more active, or having different or similar activity, okay. So inside the body, due to that chemical transformation, the drug activity may change, okay. That drug may be less active, more active, or having different activity. This process of chemical alternation of a drug, the process of chemical alternation of this drug inside the body of a living organism is called as drug metabolism. So the chemotherapy involve administering the drug in the required dosage form, okay. So we are taking the drug, okay, in a required dosage form through the suitable route. So different routes are available to take the drug, okay. So what are the different routes that we had learned in the last semester? So there are, depending upon the depending upon the what nature of the drug, you are taking the drug by different route, okay. So the drug has to go through the several stages or processes before it exhibit the desired physiological or biological action, okay. So what, uh, before the drug has to go the different physiological, or what you can say, that the different stages, okay, before it shows the biological action, okay. And once that drug shows the biological action, okay, or once that drug shows the pharmacological activity, okay, that the removal of the drug and its product after it, it also important, okay. So once that drug shows its activity, okay, in your living system, it is important to remove that drug, okay, by your body, and whatever the byproduct generated, okay, it is also very important, okay. Otherwise that whatever the side product, okay, after that chemical alternation, that byproduct may also have some side effect, serious side effect, okay. So there are different what you can say, that steps are there, okay. So when you take the drug inside the body, okay, first that drug absorb in your body, okay, first that drug absorb in your body. Then once that drug absorb in your body, a distribution takes place, drug distribution takes place, okay. So where the action is required, the drug reaches to that particular site of action, that is nothing but your drug distribution. Then once that your drug reaches to that particular site of action, okay, the next step is biotransformation, okay. So if we are using, if that drug is prodrug, okay, so that drug undergoes chemical transformation to get its active form, okay. So different types of enzymes are there, okay. So that drug undergoes biotransformation. Then once that drug undergoes biotransformation, then that drug show its effect, then the drug show its effect, okay, on the particular site of action. Then once that drug show its action, okay, on that site, the next step is excretion of a drug, okay. excretion of drug is also important. So there are different routes are there by which you can what that your body can excrete the drug. Okay, so the renal route, biliary excretion, through the lungs, through the intestine, through the skin, and through the milk. So these are the different what the routes are there. Okay, by which your drug is excreted through this what different routes, that is the renal excretion, then biliary excretion, through the lungs, through the intestine, through skin, and through milk. Okay, so we'll see one by one. First, drug absorption. Okay, so when you take the drug, okay, the first step is drug is absorbed in your body. Okay, so what is by drug absorption? So the process of getting drugs, from its dosage form into the body is known as absorption. Okay, so the process of getting the drug from its dosage form into the body is known as your absorption. Okay, so that process is called as absorption. Okay, the process of getting the drug from its dosage form. You know that your drug is available in the different dosage form. Okay, so in the last semester also we had learned the different dosage form of a drug. Okay, different, that is pills, tablets, different dosage forms are there. Okay, so whatever the what you can say that the process of getting drug from that dosage form into the body of a into the body is known as your drug absorption. Okay, so and this this process, okay, this process getting the drug from its dosage form, okay, it varies according to the modification of dosage. Okay, so it varies according to the you can say that modification of dosage form. Okay, so and this the variation in drugs chemical structure. Okay, so this process also affected by the structure of a drug. Okay, so some groups or some functional group may hinder the activity, or some functional group enhance the activity, biological activity of a drug. Then mode of administration. Okay, so by which mode you are taking the drug, whether it is oral route or a intramuscular or intravenous route. Okay, so this process, this method, this mode affect the drug absorption. Then the time of administration. Okay, so the time of administration also affect the drug absorption, that is time interval between two dosage. Okay, so if the what the time interval between two dosages is large. Okay, so sometime what happened due to this large time. Okay, this also affect the absorption of a drug. So these are the different factors, okay, which affect the absorption of a drug. Variation in chemical structure of a drug, the mode of administration, then time of administration of a drug. So for efficient drug absorption, solubility of the drug in the body fluid is modified, altered, and sustained or invented intervened according to the drug dosage form. Okay, and the route of administration. Okay, so for having good absorption of a drug. Okay, so its solubility and what is its solubility is altered. Okay, so that you can drug can easily absorb so that your drug can easily absorb, okay, into your body. And we are changing the routes also, by which mode we are taking drug. Okay, so by changing the mode of administration, okay, it increases the absorption of a drug. So absorption of the drug is regulated in order to obtain definite concentration of the drug at receptor site and required period of time. Okay, so we are regulating the dosage of the drug. Okay, so that the concentration of drug, the need of the drug at that particular side of action. Okay, and for required period of time. So so what the drug absorption maintains by the concentration in blood which circulate all the organs and fluids in tissues of the body and muscles, heart, liver, brain, and kidney. Okay, so what the drug absorption maintains the drug concentration in the body. Okay, so if your drug present in a higher concentration in your body, okay, so it mix with your blood, okay, and what you can say that uh, it passes or it transfer to all over the body, okay, whether it is muscle, heart, liver, skin, kidney, okay. So the drug absorption is proportional to the concentration of drug at absorption site. Okay, so drug absorption is directly proportional to the concentration of the drug at absorption site. So absorption is done by passive diffusion and penetration through the cell membrane. Okay, so this absorption is done by the passive diffusion. So by passive diffusion, drug is absorbed. Okay, and the penetration through the cell membrane. Okay, so it can penetrate, drug can penetrate through the cell membrane. Okay, which is related to the drug lipid solubility. So the dissolution of the drug in the body fluid at absorption site controls the rate absorption, which turns influence the extent and duration of the pharmacological effect. So dissolution of the drug in the body fluid and absorption site controls the rate of absorption, which turns influence the extent and duration of pharmacological effect. Okay, so and then we'll see what are the factors that are responsible for absorption of drug. Okay, so there are some factors are there which affects the absorption of a drug. So in that, the first point is the solubility of a drug. The solubility of a drug, the first point is solubility of one. Second one is the crystalline form and salt form of the drug. Crystalline form and salt form of the drug. Okay, so for example, the codeine phosphate is more easily absorbed and it is more soluble than sulfate form. It is more soluble than sulfate form. Okay, so crystalline form and salt form of the drug. Okay, so this also affects the absorption of a drug. For example, your codeine phosphate is more easily absorbed as it is more soluble than sulfate. Okay, so sulfate, the codeine sulfate is uh, less easily absorbed than your codeine phosphate. Codeine phosphate, due to the presence of this your sulfate group, due to the presence of the sulfate group, it is more easily absorbed than codeine sulfate. So the crystalline form and salt form of the drug is very important. Okay, so here the we have taken the example, that is salt form of a drug. Okay, one having a phosphate group and one having sulfate group. The drug is same, but the its for salt form is, one is in a phosphate form and one is in a sulfate form. So this drug codeine phosphate, it is more easily absorbed and it is more soluble than sulfate form. So this is one of the factors which affect the absorption of a drug. Okay, so in this example, you can say that this your codeine phosphate is more easily absorbed than its sulfate form. If sulfate form of drug is there, that less easily absorbed. Okay, so and this codeine sulfate affect the drug absorption. So whether your drug is crystalline form or salt form, it affect the absorption of a drug. So this is the second point. Next point is the rate of disintegration in a gastrointestinal lumen. Okay, so the next important point is, when you are taking the drug, it goes into your gastrointestinal lumen. Okay, so rate of disintegration, at which rate your drug is disintegrated in your gastrointestinal lumen. So the rate of disintegration of drug in gastrointestinal lumen or a tract. This depend on pH of gastrointestinal tract. Okay, so the rate at which your drug is disintegrated, it depends on the pH of gastrointestinal tract. Okay, and the mobility of a drug and the presence of acidic, basic, ester and amide functional group. So this depend on pH of gastrointestinal tract, mobility of a drug, presence of functional group, that is acidic, basic, ester and amide functional group. So the rate of disintegration of your drug in gastrointestinal tract, this depend upon the mobility of a drug, then pH of gastrointestinal tract and the presence of acidic, amide, ester and basic functional group. For example, the drug which having basic functional group, the basic groups, the basic, or you can say that basic drug are more easily absorbed in a stomach where pH is in a acidic range. Okay, so the basic drugs are more easily absorbed in a stomach where the pH it is in a acidic range. So in your stomach the pH is in acidic range. Okay, so the basic drugs are more easily absorbed, while while the reverse is the acidic drugs are later absorbed in a intestine. It is absorbed in a intestine where the pH is in a basic range. Okay, so simply the what you can say that the acid base reaction may take place here. Okay, so suppose your drug having basic functional group, that is amino group should be there for basicity. So your drug having amino functional group, basic functional group. Okay, so that drug is more easily absorbed in a stomach where pH is in acidic range. Okay, so what happened, the salt formation of the drug may takes place, and you know that what once your basic functional group react with your acid, it forms salt. Okay, and it will dissolve. Once it dissolve, it will get easily absorbed. It will what, easily absorb in a stomach. Okay, so depending upon the presence of functional group. Okay, so the basic drug are more easily absorbed in a stomach because the pH it is in a acidic range, while the drug which having acidic functional group, COH functional group, are absorbed in a intestine. The drug which having acidic functional group, COH functional group, or sulfonic SO3H functional group are absorbed in a intestine. That drug are absorbed in intestine because intestine the pH is in a basic range. Okay, so what, here also the salt formation takes place because in your intestine the basic pH is there. Okay, so your acidic drugs are more easily absorbed. It form your salt of that drug, and it will get easily absorbed. So depending upon the presence of acidic and basic functional group. Okay, so the basic drugs are absorbed in a your stomach, while the acidic drugs are absorbed in a intestine because the pH because of the pH. Okay, so the rate of disintegration of gastrointestinal lumen, this depend on the pH of gastrointestinal tract, the presence of acidic, ester, amide and basic functional group, and it also depend upon the mobility of a drug. Okay, so the drug which having basic functional group are easily absorbed in a stomach because in stomach the pH is in a acidic range, while the acidic drugs are easily absorbed in a intestine because in intestine the pH is in a basic range. Okay, so this is the fourth factor. Fifth one